I'm Lamont from the Uniminds team, and I'm going to be presenting a Sustainable Development Goal classification tool. Policy formulation and its implementation or research funding should be informed through research-based evidence. The opportunity exists to improve the South African SDG Hub's research classification platform to enable this. Our research questions were, can the classification accuracy of research articles be improved relative to the 17 SDGs? And can it be extended to any of the 169 targets? We scraped articles and SDG tag to be able to improve the balance of the dataset. Binary term frequency and term frequency inverse document frequency were used on the abstract and target descriptions that were concatenated. We then built multi-label models for the linear support vector classifier as well as multi-class models. SVC ended up being the best model and gave us a 64% accuracy across all SDGs. Attempting at target level, we got a good F1 score of 71% for cross-validation. However, testing against holdout data only gave us 0.04. Word cloud that we picked up from topic analysis showed some new words were being introduced with the training data, so that we could improve the predictability by perhaps re-annotating the training data. Our main finding is that research can be classified by SDG if we concatenate abstracts with the descriptions, as well as balancing the training sample. Poster shows the landing page for Streamlit. I'll now hand over to Khutso for the demonstration.
Thanks, Lamont. The tool uses two models, the logistics regression or random forest. So I'm going to go ahead and choose the resample dataset, choose a feature which is made up of a concatenation of the article abstracts and their relative target descriptions. We just wait about 15 seconds. Okay, so the tool is done running. What we have here, after loading the dataset, we have a histogram which shows you the class balance. All the samples from SDG 1 to 16 have 9,711 data points. We have a tabular representation showing the fraction of the classes of each SDG. Going on, the tool then transforms the data using the term frequency inverse document. Further on, we performed a principal component analysis. And as you can see, there are some explicit clusters. You can see here, so SDG 6 related nodes, and if we come here, that's SDG 7. But what's important to note, especially in this region, you can also see class overlaps. So here was SDG 16 overlapping with SDG 12. So the model chosen is the random forest because it offers explainable features, which really shows the discriminative power of each feature that really drives the random forest model in its decision making. It formed a confusion matrix, and the F1 score for this particular model is 0.99. The gem of the tool allows you to select any text. So we'll go ahead and select 13, and then start our prediction. Let's see how well this will classify. Okay, so we chose SDG 13, and our results say the closest SDG is SDG 13. And then we went further due to the model possibly having overlaps between the SDGs. We also provide you with the next top 3 predictions, which in this case was SDG 12, 14, and 13. Thank you. Over back to you, Lamont.
Thank you, Khutso, for the good demonstration. In closing, our next steps would be to include the SDG indicator metadata. We'll balance the training data across the targets and then train multi-label model for using the one hot encoded targets and then deploy it on Streamlit.